Hello, guys. How are we doing with this solving quadratics? Huh? Do you need a little pep talk? It is not the easiest thing in the world, but totally doable because you guys are rock stars. So we are going to learn one more way to solve a quadratic, and this is what we have so far, and I'm going to kind of highlight this. We have solved quadratics by finding key features and graphing, right? We have solved quadratics by factoring, and what's happening in that situation, remember, is that we're changing something that looks like standard form to vertex form, or factored form, sorry, on the factoring part of things. So it was x plus or minus something times x plus or minus something, and that was our factored form. So we were kind of doing that, converting from standard form to factored form and then solving. Then from there, we went on and we're working with the quadratic formula. Okay, so remember the quadratic formula is finding the x-intercepts. X equals opposite b plus and minus square root of b squared minus 4ac all over 2a. It's hard for me not to sing that. I want to break out into quadratic formula song when that's happening. So this is what we have so far. We have graphing, we have solving by factoring, and we have solving using the quadratic formula. And the last step, or the last piece that we want to add to our tool belt, is to solve using square roots. Okay? So for this week's assignment, I'm going to give you some examples here. I'm going to work through 3 examples. You've already seen me kind of introduce this with one other video in my basement classroom, so you already have a little bit of an introduction. And then your assignments this week are going to use the quadratic formula and solving with square roots. Okay, that's going to be our focus this week. All right, let's get to these examples, guys. All right, now everything you're going to be working with this week is going to turn out kind of nice and neat. And what I mean by that is, when you get to the part where you're taking the square root of a number, most of the numbers, if not all of the numbers that you are going to be encountering this week are going to be perfect squares. Okay. So numbers that are perfect squares, when we take the square root, okay, we know the square root of 25 is just an integer. It's not a decimal. It can't be simplified any more than to just write it as plus and minus 5, right? Because 5 times 5 is 25, and negative 5 times negative 5 is 25. That's why you have to include both answers, all right? This one would be plus and minus 3. This one, as you take the square root of both sides, would be x equals, what do you think? Shout it out. Good job. 7. Okay, so keep that in mind. You are not going to encounter problems like this too much this week, where you get something like x squared equals 31, and we have to write our answer in terms of the square root. But we can do that too. You would just write the answer as x equals plus and minus, and you would just leave it as the square root of 31. Or if it was an applied problem, you could change it to a decimal, right? You could put that in your calculator and get the decimal. So a little extra info there on the side. So let's jump on these. All right, guys, here we go. Let's kind of keep our lecture moving. Example number 1, you're going to isolate the x squared, and I talked about this in my other video, so we're just going to work through these fairly quickly. If you need to, pause the video and work through the problems yourself. You see them, they're all right here, 1, 2, and 3. If you want to do that, and then double check your work with the explanation I'm about to give. That is a really great way to study mathematics. So try the problem first, then check out the answer. All right. So if you like to do that, now is a good time to pause, try these three, and then kind of come back to it. Okay, here we go. So this is going to be x squared is equal to 9, 63 divided by 7, and to get rid of the squared, we're going to take the square root. So we know our answer here is x is equal to plus and minus 3. Ta-da! Okay. These next two get a little bit trickier because what is squared is an entire expression itself. So let me show you how you deal with that. All right. We're still going to get it by itself. So I'm going to add 7, add 7. All right. This is going to be 49. On this side is an entire expression that is squared. So I'm going to go ahead and take the square root of both sides, and then I'm going to have to do a little more algebra. So I'm going to get rid of this squared with my square root, and then I'll show you where we're going to go from there. So I take the square root of both sides. I get plus and minus 7 on this side of my equal sign, and over here I have this entire expression of x minus 8 still left. Okay, here are where your two numbers are going to come from. Okay, one of your answers is going to come from 7 equals x minus 8. Your other answer is going to be a different equation using negative 7 equals x minus 8. Okay, so now to get x by itself, I'm going to add 8 to both sides. So I get 15 here. If I add 8 to both sides here, plus 8, I get 1, x equals 1. So those are my two answers, x equals 1 and x is equal to 15. And remember, each time you're doing this, what you're solving for is the x-intercepts, also called the zeros, also called the roots of your function. Okay, all of these things are helping us find those x-intercepts. All right, one last one, and then we'll be done. You guys can go crush your assignments because you'll have so much good learning under your belts. You'll be ready to go. Okay, let's try this one. Again, your goal is to get this little expression that is being squared by itself. So let's work away from it. Let's start with things that are kind of not tied together here. Let's start by subtracting a 3. All right. So on this side of the equation, it looks like I have 5 times the quantity x minus 2 squared, and over here I have 125. Perfect. My 5 is tied with multiplication. I still am trying to get this piece that's being squared by itself. I'm going to divide both sides by 5. My 5's cancel. X minus 2 squared is equal to, woohoo, 25. I know 25 is a perfect square, so that's going to work out nice. So here we go. We're going to eliminate the squared. What's left on this side of my equation is everything in parentheses. And over here, the square root of 25 is going to be plus and minus 5. And here's where you do your breakout into two separate equations. Right here. One of my equations is x minus 2 equals a positive 5. My other equation will be x minus 2 equals a negative 5. And let's go ahead and add 2 to both of these bad boys, and we get x is equal to 7 and a negative 3. So 7 and negative 3 are our roots or zeros or x-intercepts, these all mean the same thing. Okay? And that is where your parabola will cross the axis, specifically the x-axis. Okay. Excellent work, guys. If you need to rewatch this video to help you out with the examples, do that. If you need to get a hold of me next week to go over a couple extra problems, don't forget that we have Thursday office hours. I'll put a link in week 4 folder for you. And I know you guys are going to do great this week. Hopefully you're hanging in there and having a good time with some sunshine finally this week. All right, guys. Miss seeing your faces. All right, stop by and say hi. Good luck.